హాయ్ ఫ్రెండ్స్, ప్రతి క్షణం ప్రజల కోసం మీ జనతా న్యూస్ సబ్స్క్రైబ్ చేసుకోండి. అలాగే పక్కనున్న బెల్ ఐకాన్ నొక్కడం మర్చిపోకండి.
Basically, maintenance and keep accurate records, proper start through system knowledge, then through diagnosis people then inspect the failing compressor because it's going to give you more information than what the really cost of the failure. If a compressor fails and the process not be determined and eliminated, the compressor is bound to fail and nobody can stop it. Let's see now. A unit that is not working at all is easier to diagnose than one is running but not going anywhere. Because it's not working, we know that exactly what exactly is happening. You can see which one is tripping, then we can see the wrong. So the following what we wanted to go through it from around the 6 to 7 points, which is the real troubleshooting which is happening in the system. So let's see now. So what are the things that could cause a high head pressure in a system? It could be a small unit or big unit, but you might say. Taking the broad sense now, only 8 things which can cause a high head pressure. That means not enough air or water passing through the condensers, and also the entering water temperature or the air ambient is very high than the design. Yes, that could cause high head pressure. Lower charge also can increase the high head pressure because it is occupying the condensing space. Block corroded insulation, that means basically on the scale inside the condensers of water cooled and then the complete dirt of the air cooled condensers can increase high pressure. A restricted flow only is going to back up the condenser space, so that can also lead into the high pressures. And not condensable, that means we should have only gas in the proper true gas. Anything other than inert gas, all inert gas is going to give high pressure because it's not condensable. So higher than the normal load, yes. And mismatching components, yes. Say an undersized compressor, if it's working with the bigger evaporator, is going to lead into that. Mixed refrigerant, yes, that can also lead into that. Let's see now what are the which can cause a high suction pressure. Again, this is also another heavier than normal load, higher than the normal head pressures, then refrigerant flow from the operators, and lower compressor. Again, that can also lead to the unable to pull down the evaporated gas. Then higher than the adequate air water flow through the evaporator, that means again in inverted load, extra load, the wrong or mixed refrigerants. Then if the compressors is leaking valves, that can also lead into that. Even hot gas 3-way, 4-way valve leaking also can backfire. What are the things which a compressors can really taking low amps or high amps now? So here again, now basically a low current draws indicate that means a low suction because it could be because of the expansion wall choke or dry air is choked or something like that. Then only the suction is going to be low. So anything on low suction, it is directly related to your low amps. Then what are the things which can go into the high discharge temperature? I was mentioning now the compression ratio can lead into high discharge temperatures. So whenever you do analysis, at the time you need to see how much is the suction which is gone beyond lower than the design. So that can lead into higher discharge temperatures. Now, the compression ratio or the leaky discharge valves or a blown gasket can take into higher discharge temperature. So equally low discharge temperature is also dangerous. So whenever a liquid come back into a compressors, that will lead into a lower discharge temperature. So this is also lead into a compressor's failure. So then what is either a low or high subcooling in the liquid whenever it comes out now? So we all know that subcooling is not a liquid when it comes beyond the saturated temperature. So when it goes further beyond the saturation temperature, whatever it is temperature difference in the saturated liquid and the outside liquid is called a subcooling. So every designers will have a subcooling of around 5 to 10 degree Fahrenheit. Okay. So whenever anything is there, anything higher than 10, it shows that I think that it could be overcharged and it is subcooling more. And then whenever it is less than 5 degree or 2 degree and all, it shows that it's a lack of refrigerant in the system. So then, of course, this has to be validated by taking the other parameters and analyze, then go to the real root cause. But this will give an indication to you. Okay. So Similarly, the whenever same thing, the temperatures we have shown, how much it should be, the difference in 110, 15 to 105 is the 10 degree Fahrenheit subcooling. So again, it is on the freezer's case, and whenever capillary tube, when it is boxed is pulled down, then you will have a difference of cooling that area. How do we determine the proper refrigerant charge in any kind of systems now here? Here again, now TXV or capillary or the metering device you have now. So generally we keep an air conditioning application around 10 degree Fahrenheit superheat, and if it is a cold room and other application, we go around 6 to 8 degree. Okay, and of course if it is the low temperature, people know it's around 4 to 6 degree. Okay, so if anything beyond that now, and if the subcooling is more, then we know that it is the refrigerant charge is not correct. So the best way is to, if at all, if nothing can be done, if you have a side glass, then remove that extra gas until the bubbles started coming back. Then we can charge another addition 1 or 2 kg to make it round. So this is a normal thumb rule would work. But the best way is to remove the entire gas, weigh it, and charge it. That will be the best way in case if you have a doubt in the system. Low side closed wall and high side closed also follow the same system now here. So how do we check the operation of the metering device? But here, same thing I was telling that about the superheat is the only thing which can indicate how does, as provided the refrigerant charge is perfect. Okay. Then of course the fine tuning can be done based on the adjustment. Okay. So here we have talked about the capillary tube when it is, how it is functioning here. So you can please go through that. And then the majority of the systems, whenever we found the water, so the water quality, especially on the condensers which is being used and the chillers we are used, that can also cause a trouble, and we need to know what the thing which is making a scale to form here. So this is the recommendation here. Now if you go through that, what is the makeup water which is supposed to here function, and then how much is this based on that. Now then we have also chilled water, because chilled water is the one which generally neglected, because we don't the scale is one indication in condensers. Yes, that water is scale, and then it is alkaline, so people will take care of on that treatment now. But whereas in chilled water, unless it's failed or something, any purpose, then we come to know. Okay, and of course there are many things are nowadays being monitored on a facility team and all. But whereas chilled water generally, what is happening, especially when you have that iron content. So the two ways we generally go into that. One is that one is iron, and second, whenever we drain the water and see the color, so that is going to tell us what exactly is happening inside. But beyond that, these parameters need to be maintained in order to avoid the scaling and also corrosion. There are two things which can give trouble into our water systems. Then another thing now for analysis, what is happening inside, because when a sealed system, we really don't know how internally. So the best way is to know my system is internally, whether it is in corrosive refrigerant inside is there, or any moisture is there inside. The best way is to remove the lube oil from the compressors, or at least on a yearly basis, get it analyzed, then compare with the parameters which is given here. So this will going to lead us to what exactly is inside the operating conditions now. Okay, a moisture higher than 100 ppm is a clear indication that I have moisture inside. That means, so somehow I have not done the proper vacuumization, or whenever I done the repair work, I had not done complete revacuation now. Okay, the tan is an indication of the acid number. So anything beyond 0.2, so that means it is the reaction of moisture is already taking place inside. You know, the refrigerant and moisture mixed together form hydrochloric and hydrofluoric acid. So these hydrochloric and fluoric acid can, whenever in circulation, can react with the windings, and then slowly it's going to start eating away the enamel now. So that is where the problem started. So we need to keep a close monitoring on this moisture and the tan parameters now here. Of course, then whenever and after long running, if you find that tin, aluminium, then iron contents of if it is increasing, so we know that the bearing surface is getting worn out. So that is an indication that I need to plan for my yearly overhauling and all. Then the oil conditions and how much is diluted, how much is that particular, it can withstand the lubrication property. We can see by the viscosity at both 40-degree level and 100-degree level. So this is a recommendation given here. So please go through that. So this will also help you to monitor whenever you go for troubleshooting, especially when you have frequent winding failure and frequent compressors failure here. So here again, so there are whenever you do for a troubleshooting now, never ever use the cooler. That means the screw compressors, whenever you want to pump down, never ever go beyond 100 kPa. Any screw compressors, because you know that screw compressors, both loops are all separated by only oil, and oil is only getting separated here. So whenever when you go beyond that, then 1100 kPa, so there is a possibility of a corona action that can lead into a failure of the loops here, the lobes here. So in that case, required always use a refrigerant recovery unit. The compressor oil filter should be checked after a first year of operation. Then subsequently, after every 4,000 hours, you can see depending upon the pressure drop. A normal pressure drop of any filter should be should not go beyond 2.1 bar. So if it goes, that means then it is completely choked. So please arrange to get it from the manufacturers and get it replaced now. So indication is low saturation suction temperature is not an indication to low refrigerant charge, especially when the oil foaming occurs in a cooler. So in a cooler, so whenever the oil goes into the cooler, so oil is a very good insulator. That means that it is whenever it is going to form on the evaporated tubes, so the heat transfer is not going to take place. So when the oil is there in the system, then your naturally saturation suction temperature will be lower. So you should not think that it is because of any refrigerant metering device problem. So before that, you need to first collect the oil, then only you need to go into that level. So never again apply a measure on a motor winding when the system is under vacuum. So you know that the corona effect which can happen. And use only in high vacuum pumps with a ballast arrangement for achieving the deep vacuum. That is where which this can lead into your the moisture level beyond to specified. So we know that practically many times we have seen that now because of this practice is not being followed, we found that the ppm level is going always higher on the moisture level. So whenever you have to remove the gas from the system of any, especially water-cooled systems, so you need to circulate the water. So if you do not circulate the water, there is a chance of tubes getting frozen. So you know that whenever we remove the gas, that the low pressure is going to create. That low pressure directly proportional to the low temperature, it can freeze water in the tubes. So try to avoid as much as whenever you have to remove, circulate the water and remove it now. So always keep the oil heater on. Okay, you know that the absorption of oil from the refrigerants, when higher the oil temperature, the lower the absorption capacity. So that is why we always keep the oil on conditions, especially on the chillers, eccentric chillers, at even when the chiller is not running. Now, okay. So this can lead into unnecessarily the oil carryover in the system. So just to separate same chemicals while these scaling the consumptions, always use rotating brush for high efficiency internal spiral tubes. You know that modern compressors and condensers are all really internally spiral, externally formed because to improve the higher efficiency. But unfortunately, within 3 to 6 months, we have many times we have seen completely it is and whatever. Local is required for troubleshooting because you and troubleshooting now. Either you do by manual or you do by PMS, but this is going to really help us in the long run. Okay, this is going to give a trend and also which can lead into a really nearest trouble. Okay, and closely monitor all the vital parameters that will consume more power, especially okay today with the energy conservation. So I know people may be doing it now, but this is the suggestions now, especially because it's an indirectly it is going to affect you. The one is efficiency. Not only that efficiency, it is also going to lead to the failure now. For instance, running continuously with higher discharge pressure is going to consume more power, no doubt. But beyond that, it is also going to be a high discharge, high temperature, and also it can lead into the failure of the compressors. So take immediate action whenever anything is happening, and do not wait till that okay everything comes now. At least assuming that okay when the discharge is high or the compressor is making noise, or at least you can try to bring down the capacity so that it will run with an optimum level till you take the corrective action now. Keep your eyes tuned to the machine's operating, since most of the major breakdowns do not occur instantaneously. It generally starts with smaller thing, then it aggravates, then ultimately it leads to the fail. That is what I was telling now. The operators is the really guy, people who are there near to the, we are not there always, but they are there always near to the machine, and they know the tune of the machines now. So they are the very key persons now. We need to train them always, and also we need to give them the do's and don'ts. Okay, and whenever any small thing happen, and we need to guide them to take the immediately quick corrective actions over there, so that to avoid the major breakdowns here. Be attentive to the chillers, gives indication some issues through alert and alarms. So we already discussed now. Okay, and because now every alert is a first indication, then alarms is the second indications now. Okay, now follow the manufacturer recommendations as per O&M manual. Everybody has given a lot of information on the O&M manual. Please read it now. If you have doubts now, talk to the experts and whoever comes to your place, or you can call, talk to the specialist. They're always there to help you. Never bypass the safety controls. It all meant for safety only, safety of the equipment and safety of the persons working nearby now. Please let us not do anything on that. Even if it is the case now, unless otherwise, we talk to the manufacturers, talk to them, and then you can take corrective action. Update your knowledge by participating in OEM's training session. Of course, a session like this now through share service programs, it always bring your knowledge to you, and it also upgrade our day-to-day operation level. Whenever I was telling that beyond God's giving the tools, now we can also use the latest techniques now. Whenever we found to really the root cause, the nearest one, and also how the accuracy level, you can use all that diagnostic special tools, which generally people use it now. So very difficult with this timing to explain each and everything. But if whenever anything who wanted beyond anything is there, we are ready to help you on this now. And be safe. Okay, the God has given us one life, so we should never ever take any bypass conditions. Always, whenever you are on not everybody can solve all the issues, nor any one person can be the master of all kind of issues. Hence, nobody should feel below the dignity to ask or refer the issue or seeking to others' opinion. Nothing wrong. Help in case if he is not able to resolve them. Please talk to your higher ups, your colleagues, or anybody seniors. Nothing wrong here. That is the way I have learned in this 41 years now. Okay, that's all with this now. I thank you very much for all this thing now. If any doubts or anything is there, you know the subject is very, very huge, and whatever in this 45 minutes, 50 minutes, and we could bring down some of the gist of this one. Now, this is basically a one-day session. We not to take in Institute of Excellence shape, but we condense this and try to give you. And I'm sorry for that, but in case of anything is there, if you have any doubts, we are there as a panel to support all the questions, whatever you are posting now. Thank you very much.
Yeah, thank you, Ganeshan sir. That was a very, very detailed one. In fact, the topic is so much relatable in these days, as you can correlate it to the incident what has happened in Vizag, the neighboring state. That because of the lack of maintenance and shutdown, disaster has happened. And this is so related topic, and very thankful for that. This was a very detailed one, which includes theory and practicals and what are the pragmatic challenges and everything. So, like facts for that. We will now just move on to the session. Let's see, sir, if audience have any questions and how can we address that. I just read out the questions for you, sir.
Yeah, please.
Okay. So the first question is from Suresh A. What's the difference between slugging and flooding? And by using economizer, can we avoid these issues?
Okay. What is the second question? Slugging and flooding, I understand. What is the other one?
By using economizer, can we avoid these issues?
Okay. Economizer. Okay. By using economizer. Yeah. Okay. Yes. Yeah. Okay. So as I explained to you, go to that. Yes. Flooding. Flooding is not continuous. Yeah, flooding is nothing like a liquid continuously coming back. Can you hear me?
Yes, sir, we can hear you.
Yeah. Please go on. Flooding is nothing but a continuous liquid which is coming back from the evaporator. That means unevaporated liquid coming back into the compressors continuously is called flooding. Okay, maybe because of the expansion wall adjustment is not properly done, or it is not properly insulated properly here, or anything which is unevaporated liquid continuously coming is called flooding. It is going to give trouble. That means that liquid can going to come and settle down in the evaporator. Okay, may not be major problem, but during every starting, this is going to give trouble because it is going to throw away all the oil whenever I was telling that. So this indication now, if your side glass is it is forming like this, the indication that liquid is there already. So this is what I was telling now. A liquid is there continuously means the whatever liquid coming here is going to settle on the bottom. So in operation, you will see the foaming. But whenever it restarts, so the whole liquid is going to come out along with the oil. Then the damage is going to take place here because the compressor is designed for vapor compression. When I put a liquid into that, now it is going to develop normal 300 psi. It is going to develop 2000 psi. So this can damage all your reeds, wall plate, or anything. If it is scrawled, then that also is going to give trouble. So this needs to be avoided. This is a flooding. Okay, slugging is nothing but you can see because of the low flow on the evaporators or the liquid trap. Actually, whenever the liquid is proper trap is to be there. If it is not properly done, then some amount of liquid along with the oil is going to get trapped here. So that whenever the second restarting, whenever you start from the second cycle, that heavy liquid and oil going to come in one lump, which heavily is going to come and attack the compressors. So that is called slugging. That is the two difference here now. So your second question of economizer. See, using economizer is only generally we use it for the improving the cycle efficiency. Okay, so maybe but here most of the economizers, unless you have a liquid suction heat exchanger here, probably that may improve a little. But in modern economizers, what we call here, we are trying to use the economizer here in the liquid line. We take some portion of liquid and cool the remaining liquid so that I can improve the cycle efficiency. That is where the current economizers are using. So we are not able to save anything by using economizers, but whereas you can use, if at all, if you have liquid suction heat exchanger, probably in our olden days we used to see that now. So that can eliminate a little, but again not 100%. Hope I answered the question.
Yes, absolutely, sir. That's a clear one. Moving on to the second question, we have a question from Kalimullah. Difference in superheat in air conditioning system cooling versus heat pump. I'll repeat the
Okay.
question, sir. He's asking, what is the difference in superheat in air conditioning system cooling versus heat pumps?
Okay. So heat pumps is nothing but then again then improving the cycle efficiency of the things now. So there I'm not finding any difference into that now. The application depending upon the application, the manufacturers have recommended us to do that now. The superheat is remain same. So that means I will not go beyond that recommendation of the superheat there. Okay. But here, what our superheat, what we are talking is the expansion of superheat here. But there, if you see that because of the cycle efficiency, so they try to minimize that the on the heat pumps in that case. Okay.
Okay. So I think we are falling short of the time. I think I'll take the last question, sir.
Yeah.
So I selected the terms of questions also because, yeah.
No problem.
Okay. There are two questions from Ranaveer Singh. I'll select any one which is interesting. Okay, there is one theoretical question I think which you have already covered in your presentation. There is one problematic question which you have asked in terms of number. How does a small capacity say below 10 PR chillers performance varies at a part load conditions compared to big capacity chillers above 50 PR?
Okay. Yeah.
Yes.
Part load again.
That he hasn't mentioned. So I think he might part load.
Okay. So he wanted to know the difference. What will be the difference if it is 10 TR part load and 50 TR part load? Right. Correct. So I don't know whether he's referring to the performance or the operating conditions or the part load. Is performance is referring? What is actually question? Part load? Oh. Load designed at the initial stage itself, but at plot load conditions, I am having enough area of refrigeration to do that. At pot load, I'll get the liquid length temperatures will be lower, so that I get that either by there are two ways, either by I unload the compressors so that I get that pot load efficiency, or if I have a VFD units now, then I can reduce the speed of the motor or the compressors. So then I try to gain that. So these are all the two ways we are going to get the gain, because the condensers remain same for the same time. So when I the same 5 tons 10 ton condensers, when I use it for 5 tons now, so I get a lot of refrigeration. The liquid line temperatures can go. My cycle efficiency is going to improve. So that is why we try to gain more refrigeration effect. That means if you see the refrigeration effect there more because of that. So here, that if you see both, there is no there cannot be any change whether it is 10 ton or 50 ton or even 500 tons. At pot load, if I design initial stage, if I can in selection I'm designing that at pot load, my efficiency is going to be this much. Now it doesn't matter 10 TR or 50 TR or 100 TR or 500 TR, because the funda remains same, but I need to design at the initial stage. So then I can get that now.
So considering all the questions,
all the questions, please. No, I think you can take all all the questions now. Probably, I think the time is not sufficient. Now, whereas we will try to answer to that, and we will put all the questions back to in Anand, and we will answer to all the questions now. Okay. Because probably sometime we may not be understood clearly. You do that now.
Right. Sure, sir. Sure. So, if I think maybe I can extend it for another 3 minutes up to 6 months. If you're okay, I can take a couple of more questions, sir.
Yes.
Oh, fair. So, the next question is very good question about the energy savings from Baraprasad. If we cool the liquid before the compressor, will it result in the energy savings?
If we cool the liquid before
Compressor.
Okay, see, we were only discussing that liquid should never pass to the compressor. That means if liquid is coming that means you are not really fully utilizing the evaporator capacity. That means it is not actually evaporation should be end somewhere near, and then I should get only a super saturated vapor coming back to here now. The liquid is coming, basically you may not get any cycle efficiency unless I design this liquid to use this whatever liquid coming by putting this liquid to here. That is called, we call liquid suction heat exchanger. If we can do that, then probably that may liquid this liquid which is going here, it gives up the heat. That means this liquid gives up the heat to this, thereby assuming this 110-degree liquid, when I am passing through the heat exchanger, then 110 can become 100 here, so that I get lower liquid, then it get more latent load from here. So unless I have liquid suction heat exchanger here, then only that liquid I can use it. And this liquid I can evaporate before it goes into the compressor. But I would prefer, I don't want any liquid come back into the compressor. More than efficiency, I want to save my compressor. So that should be the object of every manufacturer, and that is why they designed their metering device. If we see that nowadays expansion wall with electronic with more precision are there nowadays available. So that will take care. It will never allow the liquid to come back into that now. But fundamentally, what you say is it is possible, but these are all very old technology we used to do around 20 years back, not now. Hope I am clear.
Yes. So I think I'm going to take the last question. What are the causes of low pressure valves in small capacity air-cooled chillers, and how to diagnose them?
Okay, if I am understand correct, what are the problems with the low suction pressure, right?
What are the causes of low pressure valves in small capacity air-cooled chillers, and how to diagnose them?
Low pressure fault, right?
Yes, correct.
Okay, so we talked about low suction pressure. What are they? What are the reasons, and what it can cause the problem? Am I right?
Yes.
Yeah. Okay. Fine. So the low suction, I explained to you earlier in one of the that is one of the dangerous sign in any refrigeration systems now. Now, low suction means imagine now in a normal system, the compressor need to pump from 35 psig to 100 psig. It's a design. So instead of 35, I make this compressor assuming because of whatever reasons, from 30, it comes to 30. From 30, I need to, because condensing temperature never changes, because that's depending upon your ambient and other water cooled. So I need to again from 35 to 30. Now I'm doing from 30 to 100. So the additional work done by these compressors can lead into premature failure of any compressor. It could be a sealed one, semi-hermetic, anything. But compression ratios, it is going to damage in the long run. So what could be the reason basically? Maybe the low suction, maybe because of maybe not so bleeding blood, or could be your expansion wall is under bleeding, maybe because of the wall. I've just had the
Last question.
operation.